Hey everybody, welcome to Systems Expert. In this video, we're going to cover the question of designing Amazon. Specifically, our interviewer is going to ask us to design the system that powers Amazon's e-commerce business. So that's good. We've been given a little bit of information. We know that we're not designing Amazon Web Services or some other Amazon product, but Amazon e-commerce is still pretty complex, pretty vast, and so we have to ask some clarifying questions. The first question that I'm going to ask is not so much a question as much as it is going through the entire Amazon e-commerce user flow to confirm that we're designing all of it, or to figure out which parts of it we're designing. So let's go through it. On Amazon, you've got the homepage. I'll write it here, homepage, and this has got some recommended items for the user. Then you've got a search bar on the homepage that you can type in to find items. So I'll put search here, and then we'll just put items because you can have lists of items that are returned to you from the search query that you put in. You can view individual items. So all of that is covered in this items bullet point here. Then you can add items to your cart. And I believe that on Amazon, you can have multiple carts. So I'll put it in parentheses here because I think you can save certain carts. Then you can obviously submit orders. So we'll put just orders. Let's put orders like this. And then maybe you can even cancel orders on Amazon. And that'll be taken into account in this bullet point. So I'm going to ask my interviewer, is this the entire user flow? Did I miss anything? And are we designing all of it? So here, our interviewer is going to tell us that this is indeed the entire user flow. However, we do not have to worry about the home page with recommended items. In fact, we can just assume that the home page of Amazon consists of just a search box that people are going to type in. So I'm going to go ahead and cross out the home page bullet point. And they're going to tell us that we do not have to worry about having multiple carts. We can just have a single cart per user. So that simplifies the design a little bit. Now, the second question that I would want to ask is, for the searching on Amazon, do we have to design the subsystem or the recommendation engine that actually figures out what items to return to the user when they type in a search query? And so here, our interviewer is going to tell us that no, we don't, because that's a pretty complex subsystem in and of itself, probably has a lot of machine learning involved. So what we can do is we can assume that we have a search results recommendation engine service out of the box that has been created for us, and we just have to figure out where that subsystem is going to live in our greater design or our greater system. So that's nice to know. I don't think I'm going to write it down here, but we will remember that we will have this service at our disposal when we start diagramming things out. Now, the next question that I would want to ask would be related to items. So do we care about the stock of items? In other words, whether items are available on Amazon, whether they are in stock, or for the purpose of this question, can we just assume that items have infinite stock? And here, our interviewer is going to say that we absolutely need to handle this. We need to handle item stock because this is a pretty important part of any e-commerce business. So I'm actually going to write this maybe in yellow to point out that it is important. We'll put stock. And specifically, what this translates into is that users on Amazon should not be able to order items that are out of stock. And when they do order items that are in stock, that should effectively consume the stock, as you would expect. So that's helpful to know. The next question that I would want to ask would be a follow-up to this stock topic, and it would be, imagine we have an item that has pretty low stock, like maybe there's only one of it left or two of the particular item left, and multiple users are looking at it at the same time. how do we want to handle that? Should we have some sort of reservation mechanism or something like that? And here, our interviewer is going to say that this can be pretty complex depending on how fancy we want to be. The way we can do it is we can assume that if an item is in stock, any user can obviously see it, and they should see how much of the item is left on the sort of browsing page. And then any user can add it to their cart if it is in stock. But once they begin the checkout process, they are going to have to be alerted if the item is no longer in stock. And if it is in stock, the checkout process should kind of reserve the item for about 10 minutes or for the duration of the checkout process, and we can cap it at 10 minutes. So perhaps I'm going to actually give myself a little bit of room here by moving these orders down here, and we'll add the checkout process, which is pretty important, and we'll put in yellow reserve. So reserve, and we can put a sort of arrow with the stock because these two things are related. So that's going to be something to keep in mind as we go through our design. The next question that I would want to ask my interviewer would be, do we have to handle or design our system for everything that happens after an order is submitted? We can imagine that once an order is submitted, it gets assigned to an Amazon warehouse, then it gets assigned to like a delivery truck, a specific Amazon worker. Are we handling that, or can we just forget about all that? And so here, our interviewer is going to say that we do want to handle how orders, or rather what happens with orders when they are assigned to Amazon warehouses. So I'm going to write this down, warehouses. And specifically, what our interviewer is going to tell us here is that when you have an order on Amazon, that order sometimes has items that are individually available at different Amazon warehouses, and so therefore the order needs to be split up, right? Half of the order maybe gets shipped from one warehouse and the other order gets shipped from another warehouse, and you, the customer, end up receiving 2 packages instead of 1. And we have to kind of figure out how that fits into the design. And specifically, again, our interviewer is going to emphasize that we need to take care of or think about how warehouse item stock comes into play. So I'm going to write in yellow again here, stock, because the stock is going to be, again, kind of a focal point here. Our interviewer is emphasizing that item stock is really important in an e-commerce business. You've got a lot of parties interacting with item stock. In the case of Amazon, you've got all these warehouses, and we need to figure that out. But we don't have to worry about anything related to delivery drivers or deliveries. All of that we can ignore. It's really just the warehouses and the item stock that we care about. Okay, so that gives me a little bit more information. I do want to ask one follow-up question about warehouses and stock, which is, let's assume that there's an order with items, and that order can be fulfilled by multiple Amazon warehouses, not just one. How should we figure out which warehouse gets the order? Like, should we just do something like a round-robin approach or a randomization technique, something like that? And so here, our interviewer is going to say that we actually don't need to worry about like that part of the warehouse assignment. All that we really care about is, again, the stock, like which warehouse has stock, or if a warehouse doesn't have stock, we should be able to figure that out. But as far as all the other logic, like, if you have multiple warehouses, which one gets picked, which might be something based on shipping location or based on, some smart machine learning logic, whatever you can think of, we can rely on a special service, just like the search engine or the recommendation engine service that we had here. By the way, maybe I will write this down in blue so that we know that we have a service here. We'll put service so that we know that we have a service at our disposal. Well, here we're going to have for our orders, we also are going to have a service, which we're going to call some sort of order assignment service, which is going to be smart enough to really figure out how to split up orders into sub-orders for warehouses, which warehouses to assign those orders to, But again, our interviewer is going to emphasize that we just need to plop that service into our design, but we need to figure out how warehouse stock is going to come into play for this service. So really, again, an emphasis on this whole item stock issue. So at this point, I think that I have enough information about basically this entire user flow, including the warehouse flow, which kind of goes beyond the user. I want to make sure one last time that I'm not missing anything. So I'm going to ask my interviewer, is there any other part of Amazon that we might need to support, any other feature, like maybe Amazon Prime or Amazon subscription services where you can purchase an item on a recurring basis? And our interviewer is just going to say no, nothing like that. So this is really the entirety of the design. And so now I'm just going to finally ask a few questions about the scale of our design and the sort of system characteristics that we're looking for before jumping into the actual design. So the first one of those types of questions would be, I know that Amazon serves basically the entire world, right? Amazon has a lot of different stores and websites and businesses. It has Amazon.com, Amazon.fr for France, Amazon.in for India. What are we designing exactly? Are we designing for the entire world? Are we designing only a regional, Amazon store? And so here, our interviewer is going to say that for the sake of this design, we can assume that all of the regional Amazon stores, like Amazon.com, Amazon.in, are effectively entirely separate but identical businesses. And so we just have to design one of them, let's say Amazon.com. So I'll write it down here, Amazon.com. And our design will then be applicable to all of the other regional businesses that Amazon has. So we don't have to worry about Amazon.in or Amazon.fr. These are all going to be identical to Amazon.com, which is what we're designing today. So that simplifies things a little bit. The next question about system characteristics and all that I would want to ask would be, I'm assuming we care about latency, about reliability. We want our system to be highly available. We probably want to have really fast search queries, so low latency when we're searching for items. I'm assuming we don't care as much about fast order submission or things like that. So I'm going to confirm this with my interviewer, and they're going to tell me that yes, we do want we want very fast item searches. So maybe I'll underline this in blue, the searching, to show that we want this to be fast, but we don't really care about fast order submission or things like that. And generally speaking, our interviewer seems to want us to focus more on the core functionality of Amazon e-commerce. So maybe I'll write this down again at the bottom. We'll put this in another hyphen. Core functionality is super important. Core functionality, and less about this whole latency or high availability thing. Of course, we do want the system to be highly available, but we're told that we're going to be given highly available SQL setup out of the box. We don't really need to worry about the availability details of it. More again, the database schemas, the core functionality, how it's actually powered by our system. So that is really helpful. The final question that I'm going to ask for good measure is just the scale of Amazon, how many customers are we serving? And here, our interviewer is going to say that Amazon has something like 300 million customers, and it serves 60,000 orders per hour, which is 20 orders per second. Since we're serving just Amazon.com, the US here, we're going to go with something like 10 orders per second, half of all global Amazon orders. So I'll write this at the top here. 10, put in parentheses, 10 orders per second. But again, it seems like our interviewer wants us to focus more on the functionality of the system rather than the system characteristics. So this is just in case it helps us, but overall, core functionality is more important. So at this point, we've spent quite a bit of time asking clarifying questions. I do think that it was warranted here because Amazon is just very complex. There's a lot of stuff that we need to know, but I think it's time to jump into our actual design. So the first thing that I'm going to do is just kind of come up with a plan and make sure that we're structured in our approach. And I think that I will start with a sort of high-level overview of our system, maybe diagram a few things out and see how everything interacts with one another. Then I think I'm going to jump into the storage solutions and how we're going to store data in Amazon, what exactly we're going to be how we're going to store things like items and cart, checkout, orders, all that, warehouses. And then I'll jump into the core functionality and how it works given our storage solutions. And I think for the core functionality, we'll probably split it between users, which would probably be like the first half of our bullet points here, and then warehouses, which would be like the second half. So that's going to be my plan. Let's see how it goes. So let me give myself a little bit of space here. I'm going to take kind of a blank slate. So the first thing that we'll do is this sort of high-level overview of the system. So I think that we'll take from what I said before of splitting the system into kind of two major parts, right? The users and the warehouses. And maybe I will draw these out at the bottom. So we'll have here our warehouses. I'll put them in red. These are going to be our Amazon warehouses. So I'll put warehouses. And then we will put here maybe in white circles for our users, our Amazon users. And so keep in mind, this is all within a region, right? So this is all for Amazon.com. Maybe I'll write this at the top again. We'll put Amazon.com. And whatever we come up with here is going to apply for all of the other systems, or all of the other regional stores, rather, that Amazon has. So we have our users, we have our warehouses, and clearly, like, both of these entities are going to have to interact with our database, right? And our database is going to have to store things like, orders, items, probably carts, especially if we only have one cart per user. We can easily store that in a SQL database. So yeah, I think we're going to have like one major relational database, which I maybe will put as a sort of like big yellow circle like this. This will be our relational database, but again, at a regional level, relational DB. And the warehouses and users will be interacting with this database. Obviously, you can imagine that there's probably going to be some intermediary, API servers that handle all the requests. So maybe I'll draw those out already. We'll just put, a bunch of circles, ... Here we'll put some for the warehouses, ... And we'll put API below. Here, I will point out again that in an interview, you'd probably want to ask your interviewer if they want you to kind of, talk about the scale of these API servers, whether like the capacity of the servers is important, if it's something that they want you to touch on for the interview. Here, we're going to assume that our interviewer really is more focused on how the core functionality of Amazon e-commerce works. And so, this is enough for them. They don't care about more detail, but, depending on the interviewer, perhaps you would have to give a little bit more detail as to how this scales, how this serves, so many orders per second, and so on and so forth. But so, okay, we've got these API servers. You could imagine that you want some load balancing in between. So maybe we'll put in yellow here, LB. Here we'll put in yellow LB. So all of these requests are going to be going to the load balancer, and the load balancer is going to be tasked with routing them to API servers. And here, I think we don't need to go with anything fancier than round robin for now. So we'll just go with some round robin load balancing. Maybe I'll put it outside here, RR. And then, like I said before, these API servers are going to be interacting with this relational database, and we should figure out what actually goes into this relational database. So let me just start putting arrows while I talk. So what are we going to want to store in the relational database? Well, like I said before, I think items for sure, right? Amazon items are going to want to be in there. So maybe we will write, we'll put, one inner circle, which is going to be items. We are going to want to have, I think, orders, Amazon orders. So maybe I'll put this, I suppose, here. Let me try to fit all these circles in. Orders. And these, I think, are going to be just SQL tables, right? This is going to be a SQL table where one order one row represents one order. Same for the items here. One row represents one item. I think before I mentioned we're going to want to have a carts table because I think that it makes sense to have all of our user carts in a specific table so that we can kind of access them easily. And then the only thing that I can think about that we might need would be something related to warehouses, right? Like warehouse orders or something like that. But maybe we can talk about that a bit later. Let's first see, how these kind of fit into the user flow here, and then we can get into the warehouse orders. So at this point, I think that this is sort of the high-level overview that I was talking about. I think we can jump into the intricacies of the storage solutions and the SQL tables, but perhaps it makes sense to mix them in with the core functionality. So let's talk about the core functionality. You've got a user here, right? What's the first course of action that they take on Amazon? Well, we go back here. We saw that they search for items, right? So they type in a search query, they search for items. We have this service that we can use, and the service has to return items. We do also have to remember the stock. And then we can move into things like adding items to cart and starting the checkout. So let's see where the search service comes into play. A user calls maybe some sort of method called get item catalog or search for items, takes in a search parameter like a string, that is whatever they typed into the search bar. And so here, our API servers, they're not going to be going directly to the items table. They're actually going to be going to our auxiliary service. So I'll put maybe just an arrow here or two arrows here. And here we're going to have an auxiliary service. I'll put it in, let's put it in red, I suppose. We'll put it in red. And this is going to be our SR, search results service. Our search results service. And this service is going to be the thing that interacts directly with the items table. And so here, this performs a bunch of logic as far as, getting the best items, the ones that fit the search query the most. There's probably some machine learning in here, but our interviewer explicitly does not want us to talk more in detail about this. Now, one thing to note here, though, is that we did say that we cared about latency specifically for searching for items. So it would probably make sense to have a caching layer somewhere in our system. I think I'm just going to add a caching layer right here. So I'll add like a sort of yellow rectangle in our service, and this is going to be a cache. And the idea here is that our search results service is going to cache popular responses, or rather responses to popular search queries. You could imagine that there are probably a lot of people looking up on Amazon things like TV or like, dining room table. And for these things, based on a lot of other factors like their location or their age or what have you, our search results service is going to cache the responses so that the API servers just immediately hit the cache and come back and return to the users the items. That's going to make our searching much faster. So that is the search results service. And perhaps here I'll write in white, we'll write, get items. But I don't know if I'll write every API call, but we'll write it here, get items, and it goes up here. Now, we also need the stock of the items. So this is where things get interesting because we need to display the stock of the items on the individual pages, and then it comes into play when you begin the checkout or add items to cart. The question is, do we want the stock of the items to be in this table? Like, do we want this items table to have the stock of each item? My guess tells me no, because this items table is going to be huge, and we're going to have to update the stock of items on every order probably, or maybe every checkout process. I think also warehouses are going to have to update the stock of the items. So I would rather this table not be written to by all these other parts of the system. I would rather that this items table only be written to maybe some other service when there are new items that are added, but not like item stock. So I think that we're going to have an entirely separate stocks table. I'm going to put it, I guess, do we want to put it, I guess these, let's see, will these API servers interact with the stocks table? I think they will, because the API servers, yeah, we just said when you begin the checkout or when you submit an order, you're likely going to be editing the stock. So yes, leaving a spot here probably makes sense. We're going to put stock. Okay, so this is going to be our stock table. Now, let's go back here. So perhaps it would make sense to define the schema of our tables a little bit. So just very quickly, I'm going to define the schema of the items table here. And here, you would want to confirm with your interviewer if they want you to do that. For items, let's just go very quickly. There's going to be like an ID. There's going to be something like a name. There's going to be a description, desk. There's going to be maybe a price, right? And that's about it. Maybe I'm missing certain things, but you get the idea. Maybe a picture and with an address to like some sort of blob store or something where there's the picture for the item. But so when you get the items, right, the API servers go to the search results service, they get the items, then they go to the stock table, they get all the items that were returned from the search results service, and they get the stock to display on the pages. And so users now have the stock of the item. Now, if the user adds an item to the cart, well, first of all, if the item is out of stock, they shouldn't be able to add it to the cart. But if the item is in stock, we said that any number of users can add it to their cart, and that is not when the reservation mechanism happens. The reservation mechanism happens when you begin the checkout process. But so here, we're going to add an API endpoint, which will be something like, where should I write it? Maybe we'll write it here. Add item to cart. This is kind of like this arrow, right? Or all of these arrows. The user's add item to cart goes to the API servers, and it goes to the cart. Add item to cart, it would update like a row, the cart's a row. So here maybe we'll write out our carts table here. And put a white line. We'll put carts. So our carts is going to be, it's going to have an ID. It's going to have a probably like an items list, right? An items list, which is going to have the name of the item or the ID of the item and the quantity. So maybe add item to cart is incorrect. Maybe it should be, update item quantity in cart or something. So let me erase that. We'll put update item in cart. Takes in an item ID and a quantity, and it writes to the carts table. So this is going to be our carts table for now. I don't think we need to add anything fancier immediately. What would be the next thing? So once you have added an item in the cart, you want to begin the checkout as a user, right? So you begin the checkout, and this is where the whole reservation mechanism starts to happen. So let's write begin checkout here. Begin. I'll just put CH for checkout. And again, I'll put an arrow here. This just means that the users do begin checkout, goes to the API servers, and then goes to the relational database. And so when you begin the checkout, the first thing that we do is we probably repull the stock of all the items that we have in our cart, in our user's cart. So we need to see if these items are still in stock. And if they are not, we will alert the user, hey, your items have gone out of stock. You have to restart or something like that, right? If they are in stock, then this is when the reservation mechanism comes into play. So let's think about how do we actually handle the reservation mechanism. My guess is that we will simply update the stock in our stock table. let me just think to see if that makes sense. Yeah, you would update the stock in the stock table. You would effectively like decrease it by 1. And that means that any other user, that would effectively act as the reservation. It would kind of consume a stock, and then if you cancel the checkout, either manually as a user or after 10 minutes, we probably have the UI automatically cancel the checkout, then it decreases the stock or the relevant stocks for all the items in your cart from this table. And since these are SQL tables, right, we can assume ACID transactions, which means that when multiple transactions are happening one by one, and writing to the stock, you'll always be in a correct state, right? And you'll never have 2 users consuming the same unit of stock. So I feel pretty comfortable there. One thing that I should mention, first of all, let me just add here, begin checkout / cancel checkout, which we just mentioned. But here, I'm thinking this stock here, we mentioned that the warehouses have individual item stock because our interviewer kept, emphasizing this right here. They said, warehouses are going to have individual item stock. Sometimes the service that assigns orders to warehouses is going to have to figure out which warehouses have the stock. So here, this stock table here does not yet have anything to do with warehouses. This is really aggregated stock. So maybe I'm going to actually write this down. Let me move this stock word down here. This is going to be aggregated stock, AGGR, aggregated stock table. This is all of the stock for items across all warehouses, okay? And every item has a row. So maybe we'll write this down here, the schema of this table, right? So this is going to be the AGGR underscore stock table. This is going to have, an item ID, and it's going to have, let's say, stock. I think we just call it stock, and this is an integer. And yeah, when you begin the checkout, you reserve the stock. When you can't, meaning you diminish the stock for all the items that you have in your cart by the number or the quantity of each of those items. If there weren't enough stock, then the checkout process would have told you hey, you can't complete this, right? You're not going to be able to do this. Canceling the checkout, which is either manual or after 10 minutes, will re-increase the stock, right? And then in the event that you submit your order, so let's go to that. Here, there's going to be, we'll write it, I guess, in the middle, submit order. These are all these white texts are API endpoints, right? I know it's a little bit messy here, but bear with me. So submit order, right? The user's submit order goes to the API servers with a round robin load balancer, goes to the relational databases. So submitting the order, what is it going to do? It's probably going to delete the cart or empty the cart of the user because remember, every user only has one cart. And it's going to go to the orders and it's going to write an order to this orders table. So maybe we can write out here the orders table schema, right? Do this line again. So we have our orders, and this is going to have, something like an order ID. What else would we have in an order? You'd probably have, a customer ID, cust ID. You would probably have a status, an order status. This would be something like submitted, processing, shipped, that kind of stuff. You would probably have items. You would probably have price, a timestamp. I'm not going to write all this out, but a bunch of stuff, right? Shipping address, put ship A for shipping address. You get the idea, right? And this is the orders table. Now, when you submit an order, does it affect the stock? I don't think it does because we said begin checkout is what reserves and effectively consumes stock, right? So submitting an order does not affect the stock, the aggregated stock table. And then if we cancel an order, because we did say that maybe we would want to handle canceling an order. So I'll write this here, cancel order. cancel order, what does it do? Well, cancel order probably, cancel order deletes an order from the table, or probably doesn't delete it. It just sets the status to canceled because you want to keep track of orders. It can only be called if the order has not yet shipped. That's something that we'll need to handle with the warehouses, right? You don't want to cancel an order if it's already been shipped. And I think that canceling an order, that will re-increase the stock in the aggregated stock, right? Canceling an order will re-increase the stock in the aggregated stock. And that is how, so far, I think, all the users kind of work around this whole stock situation with items pretty seamlessly. So pretty happy with that so far. Now I think we can move on to the second and basically the last section of our design, which is the warehouse's core functionality. I will say, this is where in an interview, you would want to ask your interviewer if they're happy, if you've gone into another detail. Here, we have glossed over certain things. Like, we've gone pretty quickly over some of these things, but, keep in mind this is only a 45-minute interview and there's a lot to cover. So here our interviewer is going to be fine with what we've done. They appreciate the sort of broad, thing that we've covered. We've covered a lot of ground, even though it's been kind of in high level, not too much detail, but they're happy. So we can move on to the warehouses. For the warehouses, let's see. We have this service, right? The orders service, the order assignment service. So maybe I will write this up here in red. This will be the order assignment, so OA service. And this will be in charge of communicating with the orders table. So it'll be reading from the orders table. And it'll be likely, talking to the warehouses. So maybe and this should be in red. Let me put an arrow in red here, like this. It'll probably be talking to the warehouses. But so what will it be doing with the warehouses? We said that it has some smart logic to figure out, what the optimal warehouses are based on, shipping address, warehouse location, machine learning, all sorts of things. But it cares about the stock in the warehouses. And that's something that our interviewers said they wanted us to take care of. Which warehouses have item stock, and so on and so forth. And we have not handled that yet because right now we only have this aggregated stock. So what I think we're going to have to do is we're going to have another table for warehouse stock. So I'm going to add another table. We'll put it here, close the circle. So we'll put WH stock, warehouse stock. And this table, let's see the schema. The schema, we'll write it down here. We'll put WH stock. This will have, every row will correspond to effectively like a pairing of item and warehouse. And we'll have, an item ID. We'll have a warehouse WH ID. And then we will have the stock of the item in the warehouse. Now, this is where things get tricky because when a warehouse actually ships an item, that actually consumes physical stock of the item from the warehouse. But when the order assignment service assigns an order to a warehouse, that should also kind of consume stock, right? It's similar to when you have two users who are looking at the same item and who both want to order it. If there's only one item left, well, only one user can order it. So you have to have that reservation mechanism. Well, here, when the order assignment service assigns one order to a warehouse, if that warehouse only had one item of the item in that order, well, the order assignment service should not assign another order with that same item to the same warehouse, right? So what I think I'm going to do is we're going to have two stock entries here. Instead of stock, I'm going to have physical stock physical stock, and we're going to have available stock. The physical stock is going to be, it's basically like kind of from a cleanliness and sanity point of view, having a single source of truth for every single warehouse and every single item. How much physical stock do they have at the given moment in their warehouse? Available stock will be more similar to this whole aggregated stock thing here, where it'll be what stock in that warehouse is available. And the second that an order gets assigned to the warehouse, that will consume available stock, but not physical stock. So physical stock here, this will only go up when a new item shows up. So up when a new item stock appears, right? So like imagine a warehouse suddenly gets a new shipment of item stock, the physical stock goes up. And so these warehouses add physical stock to this table. And this is where, their requests go to the load balancer, API servers, and this goes to the warehouse stock table. And then it'll go down either when item gets thrown out for whatever reason. Like imagine, I don't know, an item is defective in a warehouse and they throw it out, or item gets shipped. If an item is shipped, that is when the warehouse physically no longer has that item, and they reduce or decrease the physical stock. The available stock, this probably goes up for the same reason as new item stock. So let me actually copy paste that. Copy, and then we will, how do we paste? Paste. So it goes up when there's new item stock. It goes down when the item gets thrown out. So I should have copied that as well. Let me see if I can copy it as well. But it also is going to go down when an item, or an order rather, gets assigned to the warehouse. So let me copy this. We'll paste it here, right? Give ourselves a little bit of room. But otherwise, it will go down, also go down when warehouse order gets assigned. When it gets assigned, and not when the item gets shipped. That way, like when the warehouse order gets assigned to a warehouse, we are effectively telling the warehouse, hey, you should reduce your available stock because you're about to have to fulfill this item and this shipment, right? So that item is no longer, or that quantity of the item is effectively no longer available, or should, decrease the available stock that you have. And so that is all taken care of by both the warehouses and in the order assignment service, because warehouse order gets assigned. This, I could put like a red underline. This is handled by the order assignment service, whereas these two things, new item stock and item gets thrown out, these are handled, and these two are handled by warehouses. And same for this one, to be honest. Now, the final thing that I think we might need is we probably need actual warehouse orders. So I'm going to add here maybe one last table, warehouse orders. And here, this is going to be very similar to our orders table. It's just going to be the individual orders for each warehouse. So, you can imagine that this would have something like a warehouse order ID. So it'd be like it wouldn't be the same ID as these orders, right? Let me actually write down the schema down here. So we'll put WH orders. This would have, WH order ID. It would have something like maybe a parent order ID, which would be the order from the main orders table, so that we know what order this is a part of. We would probably have, the warehouse ID that this was assigned to. We would probably have an order status again, but this would be like the warehouse order status, right? Has it been shipped or fulfilled by the warehouse yet? We would have items, and their items, is like a list of item IDs and their quantities and all that. We would have a shipping address, because the warehouses need to know where they're shipping their things to. And yeah, this would be something that is written to by the order assignment service, because the order assignment service is the one who actually creates all of these warehouse orders. And then, probably when it creates these warehouse orders, it probably, alerts the warehouses and tells them like, hey, you have to go check your warehouse orders. Or maybe the warehouse orders continuously pull, every like 30 minutes, they pull their new orders that they need to fulfill, something like that. So at this point, I would ask my interviewer, have we covered enough? Like, is this good? Are you satisfied? We are right around the 45-minute mark. My interviewer would say, yes, we have covered everything. Like I said before, there's a lot to cover. We did gloss over some details, but we dove into the whole stock handling pretty well. That was the main focal point of this design. We covered all the database schemas and all that. And if we had way more time, we could go into more detail on some of the other parts of the system, like maybe the scalability of the API servers, or some of the details of the order assignment, or the search results service. But this satisfies the design question as it was asked to us. So at this point, I hope that you found this video informative, and I will see you in the next one.